continuous on the closed interval, a to b, and differentiable on the open interval, a to b, then there exists a number c in AB such that f prime of c equals f of b minus f of a over b minus a. So let's talk about what that means. I'm going to draw a picture for us here. So we have some sort of function. It must be continuous from a to b, including the endpoints. It must be differentiable from a to b, not including the endpoints. Now, if it does include the endpoints where it's also differentiable, that's fine, right? And a lot of times it will, but it has to be, it does not have to be differentiable at the endpoints. It does have to be continuous at the endpoints. So if I put A somewhere here and B somewhere here, and then I'm just going to draw some sort of curve here, and I'm going to call that f of x. Actually, I'm going to adjust my curve just a little bit so you guys can see what I'm trying to prove here a little better, because those were, let's do it like this. It still would have been true for what I had drawn. It would just not be as easy to picture. All right, so there has to be a number c somewhere on A to B such that f prime of c equals f of b minus f of a over b minus a. What is this f of b minus f of a over b minus a? It's an average rate of change from A to B. It's our slope, right? So it's our slope between our endpoints, right? So let me do this in blue. So the slope between the endpoints on that segment. This is average rate of change from A to B. All right, that's our average rate of change. So it tells us that there's got to be a C somewhere between A and B, so here on the x-axis, where f prime of c equals this. What is f prime of c? What is it? Instantaneous rate of change, which when we graph, what does it look like? Tangent line, right? So basically it's saying that tangent line has to have that same slope. So somewhere here, I'm going to say it might happen about right here on this particular graph that I have drawn. Somewhere you have to have that same slope, that same rate of change. Right there. So if I had this drawn, that means C would be about right there. So in other words, at some point on the interval, the slope of the tangent line has to equal the slope of the line through the endpoints, or the instantaneous rate of change has to equal the average rate of change. Okay. It's a little bit similar to intermediate value theorem, except for intermediate value theorem, we don't have to worry about if something's differentiable. And we're talking about the value of the function, not the rate of change of the function, right? So it's kind of similar, but here we're talking about rates of change. Intermediate value theorem, we're talking about just the value of the function. So this, I love this example. It sometimes causes controversy on whether or not this is just or not. But in this situation, we need to assume that Officer Nance and Officer Shoemaker here can prove everything 100%. It might be difficult for that to actually happen, but they have rock solid proof that everything that happens here actually happened. Okay? So Officer Nance and Officer Shoemaker are both waiting on the side of I-77 for speeders. They are 6 miles apart, exactly 6 miles apart, and the speed limit on the entire stretch of road they are covering is 70 miles per hour. Officer Shoemaker sees a brand new Corvette pass her going 65 miles per hour. She calls Officer Nance to tell him to be on the lookout for the Corvette and gives him the tag numbers. Exactly 4 minutes later, the Corvette passes Officer Nance going 65 miles per hour. Officer Nance turns on his lights and pulls the Corvette over for speeding. Is he justified? What speed should he write the ticket for? Okay, so both times this car passes the cop, they are going 65 miles per hour, which is less than the speed limit. Now, I realize in reality, you're not going to get caught for this. They're not going to be doing this in reality. They're not going to be like radioing ahead on one specific car and keeping really precise records. But imagine that they were, okay? So imagine that they could do this. Did the Corvette, I said he, it could be a she. It's probably a he. Did they speed? And how can we know? We can't figure out, like, their instantaneous speed, but we can find their average speed, right? So, like, if you look at how far they traveled 6 miles in 4 minutes, but because we want this to be in miles per hour, let's change 4 minutes to hours. So, 1/15 is correct, I think. So, but let's just go ahead and get decimal anyway, because, you know, I think it's going to work out, whole numbers. But, so, you got 4 over 60, right? Which will give us 1/15 or 0.067 repeating. So 0.67 repeating, 0.06 repeating hours. If we do 6 miles divided by 0.06 hours, we got 6 divided by 0.06. We're going to get 90 miles per hour. This is his average speed. So, he wasn't speeding when he passed the first cop. He was not speeding when he passed the second cop. But he was definitely speeding sometime in between there, right? In fact, we know that he had to go even faster than 90 miles per hour. Because if he was not going 90 when he passed the first cop and he was not going 90 when he passed the second, that means he had to make up for lost time in the middle to have an average speed of 90. So he had to hit speeds over 90 miles per hour for that to be the case. But intermediate value theorem proves that he had to, or not intermediate, so I'm already getting them mixed up. Mean value theorem proves he had to go 90 at least once, right? Because we know he wasn't going 90 at the end points, then he went 90 twice or possibly more, but probably he went faster than 90 than he was 90 again when he slowed down when he saw the second cop. So by the mean value theorem, we could say, because we would know that his speed would have to be continuous and differentiable, right? Assuming that he is not capable of time travel or something here, we would have to assume that speed is continuous and differentiable. What did you say, Braden? So Officer Nance could justify this using the mean value theorem, and he should write the ticket for, he would be perfectly justified to write it for 90 miles per hour. If you want to get into a further proof, he could write it for a little over 90, but we wouldn't know exactly how much over 90, so 90 would be pretty safe. Plus, 90's like take your license sort of speeds. Most of the time, they'll bump it down so you don't immediately lose your license unless you got a lot of priors, and then you're probably, you're in trouble for that one. This is not a good situation. Don't go 90 miles per hour or more. All of you out there. Yeah. If we had time, we would do one of my Math 2 problems we used to do on stopping distance and see how much further it's going to take you to stop if you're going 90 miles per hour. A lot further. And this is in a Corvette. You could probably stop a lot better in a Corvette. How many? I don't know if many of y'all are driving Corvettes out there. I know my first car was not quite as nice and probably did not have as good of brakes and everything as a Corvette. So it probably would have taken me even longer than the Corvette to stop if I had to. Imagine the 1996 Pontiac Grand Am Olympic edition with Richard Petty's signature on the back of it. It might not get stopped quite as quick. It also wouldn't get up to 90 quite as quick either. But I did love that car. They handed it down to my sister. She hated it. So bad. Alright. So, but this is, I like that problem because it's kind of like intuitive. Like you understand that if his average speed was 90, he had to be going 90. At least once there. It kind of makes sense. So that is like one of my favorite things to introduce mean value theorem with and kind of go back to if you're getting a little bit confused, right? It's that average rate of change has to equal your instantaneous rate of change. So even though there wasn't a cop there with a radar gun saying that he was going 95, you know that he had to go at least 90 because average rate of change equals instantaneous. So let's go back to some problems that are just like naked problems, no context whatsoever, just practicing the mechanics of the math, right? So we've got this function f of x equals x minus 3 squared on the interval from 0 to 4. Find the c value that satisfies the mean value theorem. Okay? So mean value theorem, much like our intermediate value theorem, we first off have to prove that it applies. Okay? So this is just a quadratic, right? All quadratic functions are continuous and differentiable everywhere, right? So we would say since f is I'm just going to call it a polynomial function. It would be okay to say quadratic function. F is continuous on 0, 4, and differentiable on 0, 4 with parentheses. Now, I am pretty sure it is okay to just say since f is a polynomial function, it is continuous and differentiable everywhere, since that is the case for this. But I'm going to do it this way on these problems because I think it helps us remember about the closed interval and the open interval. Endpoints are included on continuous, not on differentiable. So when we run into ones that are like a little more difficult, we can still know what to do with those. Therefore, mean value theorem applies. Okay. So now what we need to do is we need to find our average rate of change, and then it asks us for the c value that satisfies the mean value theorem. So our average rate of change, we need the slope through the endpoints. To get the slope through the endpoints, we have to find the endpoints. How do I do that? What? I don't have to point slope, just the slope formula. And to get our points that we need, we're going to do f of 0, which will be 0 minus 3 squared, which is going to be negative 3 squared, which is 9. So one endpoint is 0, 9. And then we'll also do f of 4. So we'll have 4 minus 3 squared, which is 1 squared, so we get 1. So we get the point 4, 1. So our average rate of change of f on 0 to 4 would be 1 minus 9 over 4 minus 0, which will give me negative 8 over 4, which equals 2. So if they just ask us to prove that that the derivative has to equal c somewhere, or it has to equal 2 somewhere, we could say therefore f prime of c equals 2 at some point. Yes, it should be negative 2. Thank you. So we could just do that. But they ask us to find the c. So we want to find the point where this derivative equals negative 2. So we have to find f prime of c. Since they used a c right here, when I find my derivative, I'm going to use c's instead of x's for this. So I'm going to say f prime of c. And our derivative here, this is a chain rule. So we're just going to get 2x minus 3 to the first power. We'll multiply that by the derivative of the inside, which is just 1. So we actually just end up with 2 times x minus 3. I'm sorry. If I'm doing f of c, I should be using a c instead of an x right there. If you use x instead, it's probably okay. You're probably going to be all right. But because they told you it's a c value, it is better to go ahead and use that c here. So this is my f prime of c. I want to know where it equals negative 2. So I'm just going to do 2 times c minus 3 equals negative 2. You can either distribute or you could just go ahead and divide off that 2, whichever way you want to deal with it. You'll get the same answer either way. We'll add that 3. And we'll get 2, positive 2. So that falls on our interval there. So our c value equals 2. Okay. So if it asks you to find the c, I have to show that mean value theorem applies by saying it's continuous and differentiable. You need to find the average rate of change, which is your slope through your endpoints, and then you set the derivative equal to that average rate of change to find that place where that happens. Okay, questions here? All right, let's look at another one. Okay. So given that f of x equals 5 minus 4 over x, find all values of c in the open interval from 1 to 4 such that f prime of c equals f of 4 minus f of 1 over 4 minus 1. So this is the way they'll ask a lot of problems sometimes on the exam. It doesn't say anything about mean value theorem. It doesn't tell you that you're doing the mean value theorem. But we see f prime of c equals f of 4 minus f of 1 over 4 minus 1. Right? This is the slope between the endpoints here. Now, this particular problem does not ask you to prove anything, but you do want to think about whether or not the mean value theorem applies. So my function is f of x equals 5 minus 4 over x. Do I have any discontinuities in that graph? I've got one. X cannot equal 0 because denominator refraction cannot equal 0. So I know x cannot equal 0. Does that matter for the interval that they have given us? No, because we're only looking from 1 to 4. Now, if they had asked us from negative 2 to 4, the mean value theorem would not apply. We could not make any assumptions here. We'd have to say, you can't tell.
Even with x equaling 0, you still have 5. Like, it's not the denominator equation.
That is true, but it would make that part undefined. So you've got like 5 minus something that is undefined, which you can't say equals 5 or something there. So anything that'll give you a 0 in the denominator for any part of the equation is going to make the whole thing undefined. Okay? So, and you could get common denominators and see there you'll have like the same thing happen. But it doesn't affect this problem. So if I find f of 1, it is going to be 5 minus 4 over 1, which is going to give us 1. So I've got the point 1, 1. And if I find f of 4, I've got 5 minus 4 over 4, which is 5 minus 1, which will give us 4 there. So I've got the point 4, 4. Now, I did not say continuous and differentiable because this didn't ask us anything about proving. We're just finding these C values here. But if it asked us to prove, we would need to state that. So then, if I find my average rate of change, it's just 4 minus 1 over 4 minus 1, which of course is going to give us 3 over 3. So we just have an average rate of change of 1. So this is my average rate of change of f on the interval from 1 to 4. Actually, I should put this there. To find the C values, I need to set my derivative equal to this 1, which means I got to find the derivative, right? So if I'm doing f prime, they use a C in this. Yes, they use a C. So I'm going to do f prime of C. I'm going to call it C instead of x. What's the derivative of 5 is 0? It's going to go away. What do I do with the 4 over x? The easiest way to deal with this is to do negative exponents. Instead, you can use quotient rule, but the easiest way to deal with it is to deal with negative exponents. So you're just going to have positive 4 x, c, c's, c to the negative 2 there, which I could write as 4 over c squared. So to solve this, I'm going to do 4 over c squared equals 1. I will multiply both sides by c squared. 4 equals c squared. I will square root both sides. So I will get plus or minus 2 for my c. However, do I use both plus positive and negative 2? I do not. I do not use the negative because it's not in my interval. If they were both in the interval, I would use both of them. But we would say c equals 2 would be our answer for that. So at c equals 2, our slope equals our derivative. Slope to the endpoints equals the derivative. Yes? When you square root both sides of something, you should put a plus or minus. Yes. The only time you don't is like if I had c squared is less than 4. When you square root both sides there, it doesn't make sense to put a plus or minus because you can't have like less than positive or negative 2. So that's when we do like those absolute value bars like that. So if it's an inequality, use absolute value bars instead. But otherwise, plus or minus anytime you square both sides. Okay? All right. Okay, here's a table problem. The table below shows certain values for f, a continuous function. I need to change this problem. Because given what you have right here, does mean value theorem apply? What has to be true for mean value theorem to apply? Continuous and differentiable. Do we know this is differentiable? No. So I've made a bad problem is what I've done. Let's say let's make that differentiable because it has to be for us to do this problem. So if we have this and it's asking us, is there a value? It's not asking us what the value is, but it's asking us if there is a value. We would need to first say, since f is differentiable, f is also continuous, and if you want to specifically say from 0 to 10, then that's fine, or we can just leave it open like this because it is the whole function. If we look at the interval we're looking at from 0 to 10, we're going to hope that that's going to give us a slope of 1/2, because otherwise we really can't prove this. But usually they're giving you something that you can prove. So our points that we're looking at are 0, 5, and 10, 10. So our average rate of change here, we're just going to do the slope, 10 minus 5 over 10 minus 0 is going to give us 5 over 10, which equals 1/2. This is our average rate of change of f on our interval from 0 to 10. So, since our average rate of change is 1/2, that tells us the derivative has to equal 1/2 at some point, right? So, you're basically just going to say, therefore, by the mean value theorem, and just restate what the question's asking. There is an x value on the interval 0 less than or equal to x less than or equal to 10 such that f prime of x equals 1/2. Okay, here. All right, last one. All right, so this one gives us a graph. And part A says, what is the average rate of change of f on the interval from 1 to 5? So what is our average rate of change? From 1 to 5. It's 0, right? The slope of that line is 0. Okay? So the second question says, how many times on the interval from 1 to 5 does the average rate of change of f equal the instantaneous rate of change of f? Okay, 3. Where did those happen, Maddox? Okay, good. So like right here where we switch from increasing to decreasing, we're going to have a horizontal tangent right there. It's going to happen again right here and again right here, right? So our derivative is going to equal 0 at all of those points. So we would say 3 for this. Okay, questions? All right, your assignment is going to be a worksheet. Let me pass it out. And I'm going to... This is another Mr. Record worksheet here. So, I hope they pick me to be a grader this year. I want to get to be a grader and go meet all kinds a training a while back. There's a guy that's got a website called Ask Mr. Calculus. It's an old website. Like, it's not a very up-to-date website. But he always posts his solutions and stuff first. And I went to a training, and Mr. Calculus was the trainer, and I was feeling a little bit like, starstruck over getting to meet the Mr. Calculus. All right, so on these, I am encouraging you for your own goodness. You can see on the key that he writes F is continuous, F is differentiable for all of these. And then says mean value theorem applies. That would really be the best if you did that. Now, obviously, it is going to apply, and it's going to seem a little redundant on these, but it's good practice for remembering that you've got to do those. If you don't do it, I'm not saying I'm not going to give you credit for the homework, but it's a good practice to do that. And then all of the key is here on, I think he just put a graph there to show. 8 is calculator active, so whenever you get down to your equation you're trying to solve there, it's not going to be one you can solve by hand. You can solve this. I would not use the solve feature in the calculator, though, because this has got trig. I would do like we did on that other problem and graph it for that. 11 is also calculator active in the and 12. And the key is posted for this, so feel free to use that to help you there. He does a really good job of explaining things if you have any questions on it.